Hello everyone, today we'll see the discussion of day 2 60 days mentorship program. So today also I have asked 3 questions. The first one I have asked a short notes on Cope's rule, then microevolution, and macroevolution. After this I have asked a 15 marker which is enumerate the salient features of Darwin's theory, and this is one part, and the other part is add a note on its criticism. So criticism of Darwin's theory. So this is for 15 marks. So this is 2 into 10 marks, 20, and this is 1 into 15 marks. So total 30 marks, 35 marks. So principles, yesterday I said that this 10 marker should be written in 7 minutes and in just about 150 words. I said the range is plus or minus 20, so 130 to 170 words. Now today I have introduced 15 marker, so that is expected to be written in 10.5 minutes. You scale it up, it is 225 words, plus or minus 25. So maybe you can write from 175 words to 250 words. I already mentioned, don't write too less, don't write too lengthy, because writing too less will will be awarded with less marks. Writing too lengthy, you may be given a penalty for what you are for exceeding the word limit. So we'll discuss these topics like starting from Cope's rule. So Cope's rule was actually given by Edward D. Cope. Edward Drinker Cope in the year 1871. See, this Cope's rule is also known as a law of survival of unspecialized animals. You remember this statement? They can frame a question on this particular statement. So what is it? It is law of survival of unspecialized animals. So you can write who gave this theory, the year in which he has given the theory or the rule, and then the alternative name of this particular rule. So here, coming to the body, you can give the statement or the definition of this rule. So what does this Cope's rule state? It states that only unspecialized animals which show a tendency to increase body size can only survive in the course of evolution. So this is the statement of the rule or the definition of the rule. So now in the next side heading you can use the side heading explanation of this particular rule. Or we are elaborating the rule. See this Edward D. Cope, this rule is based on observation of mammalian fossil lineages. So it based on observation of mammalian fossil lineages. He observed that earlier mammals were tiny and later mammals were gigantic. So he says that there is no need to undergo any modification or create a new specialized structure. It is enough to increase body size. So increasing body size will enable the animal to adapt to any type of environmental condition, according to Edward D. Cope. So this is the explanation of this rule. Now if you see some examples, you can give the examples of some mammals like horse, elephant, camel, etc. So this is basically a rule based on a mammalian fossil lineages, because this Edward D. Cope is actually a paleontologist. He is an American paleontologist. So paleontologist is a person who studies fossils. So in his study he observed that earlier mammals were tiny in size, later they attained gigantic. So we are writing the examples of some mammals which have a big body size. Other than mammals, if you want to see, like dinosaurs or maybe crocodiles or tortoise. So these are some examples. But if you see like some exceptions to this particular rule, say for example you take a mole. Mole is a burrowing mammal. You take a bat, which is a flying mammal. Now it is physically impossible for this mole or bat to attain a gigantic size because its habitat imposes restriction on increase of body size. So it is not advantageous for a mole or a bat because of their habitat to increase their body size. So this goes against the Cope's rule. So it is an exception. So this example is against the Cope's rule. Now another thing is, yes, there is an increase in body size only till Pleistocene epoch. Pleistocene epoch is the Great Ice Age. But in Holocene epoch, the size of the body again decreased. Isn't it? So these are the exceptions to this Cope's rule. Say for example, you want to draw a diagram here. You can draw a diagram with respect to the geological time scale and body size. Say for example, on y-axis you take body size, on y-axis you can take body size, and on x-axis you can take geological time scale. So the geological time scale here, we are interested in Cenozoic, in which evolution of mammals took place, And in Cenozoic era, we are having a tertiary and quaternary period. In tertiary period, we have some important epochs like Paleocene, Eocene, Oligocene, Miocene, and Pliocene. Then we have Pleistocene and Holocene. So if we take Paleocene, Eocene, Oligocene, Miocene, Pliocene, and this is Great Ice Age, which is Pleistocene. Then Holocene, which is characterized by warm climatic conditions. So if you see the body size of mammals, slowly it kept on increasing till the Pleistocene, after which the body size again started decreasing. So as per the law, and this part is criticism. So you can draw a diagram like this which shows both the law as well as criticism. So because in Holocene the body size again started decreasing. So what are the reasons for increase in body size during Pleistocene epoch or during the Great Ice Age? See, one is having a big body size reduces the, or it has a smaller surface area in relation to the total body volume. See, this is a mechanism to conserve heat loss. So this conserves heat, or maybe you can say it prevents heat loss. Even Bergman's law also states the same thing. So this is one reason there could be an increase in body size. And second thing, an increase in size of carnivores is to hunt large sized herbivores, because carnivores also have to survive, and if they are small they cannot hunt herbivores, so it necessitated them to increase their. So this is another reason. An increase in size of egg laying mammals is to increase fecundity. That means to accommodate more eggs in their bellies, so that they can produce more eggs. More eggs means more number of offspring. More number of offspring, that means better is the ability to survive. So that is why these are given as some reasons to explain why there is an increase in body size during Great Ice Age. So the last side heading we can generate is criticism. So obviously this is not a rule, because there are exceptions to it. So this has no substantive similarity with that of laws of physics or chemistry, because in physics or chemistry a law inevitably has the same result or the consequence. So it has no similarity with the laws of physics or chemistry. And the second thing is it is just a descriptive generalization and property of animals at certain period of time. So therefore it is not a rule. So this is the format or the structure in which you can write. Such kind of answers will get good marks. We have tried to interlink, we have given the details. So introduction, statement or the definition, explanation, examples, exceptions. We have also drawn a small diagram, and then you have the reasons for increase in body size, and then we have added a note on criticism. So this is the structure of Cope's rule. See, next 10 marker is microevolution and macroevolution. So in introduction you can write what is evolution. So what is evolution? Evolution is slow and gradual changes that occur in an organism. A form or structure of an organism. So this results in some variations which may lead to formation of a new species or even a higher taxonomic group. So higher taxonomic group means above species you have genus, above genus you have family, and above family you have order, so on and so forth. So what is evolution? You are just writing in introduction. So you have slow and gradual changes that are occurring which results in some variation and formation of some a new species. So this is what you write in introduction. Then in body or explanation, if you see, you can say that evolution has two facets. One is microevolution and the other one is macroevolution. See, microevolution are small variations or small changes that occur within a population or species, and these take place for a smaller or relatively shorter time. So for microevolution to take place, it takes a relatively shorter time, and obviously here there will be change in the frequency of alleles and genotypes within a common gene pool. So obviously results in variations. So what are the factors which play an important role here? Like mutations, which are the primary forces behind speciation, natural selection, migrations, then you can take genetic drift. Migrations include genetic flow also, etc. And now, say for example, you can take the eruption of third molar, improper eruption of third molar in the younger generations. So it is speculated that this third molar in times to come will totally disappear. So this is an example of microevolution. The third molar, improper eruption. So many many people are having, many younger generation are having this issue. They go to a dentist. The dentist will simply remove this third molar, because third molar is a vestigial thing, it's a functionless thing. So this is one example. If you want to write other example, you can write antimicrobial resistance. It may include antibacterial resistance, antiviral resistance, that means resistant to antibiotics. So bacteria will survive even if an antibiotic is taken. Likewise, antiviral resistance, viral drugs will be ineffective towards the virus. So these kind of changes in bacteria, virus, or any other microorganism which are resulting in development of resistance to the drugs that are available is also an example of microevolution. So they are taking place very fast and very quick, and it is possible that such kind of variations a researcher can observe in his or her lifetime. Now macroevolution on the other hand are large scale changes. Definitely it takes a longer time. A researcher may not be able to observe macroevolution. So obviously here there is a change in frequency of alleles and genotypes culminating to form a larger change, and obviously here it results in a formation of new species or a higher taxonomic group like genus, a family, order, etc. Now here some factors which play an important role here is like adaptive radiation, then mass extinction, convergent and divergent evolution, etc. If you take the example of macroevolution, you can take the evolution of hominins from a common ancestor. So this is something about micro and macro evolution, and if you see, both micro and macro evolution are affected by same factors and similar evolutionary processes. However, they differ in magnitude and time. So I can say that microevolution forms the basis for macroevolution, and this macroevolution may lead to formation of a species, genus, family, etc. So this you can write in conclusion. So this is a very easy question hopefully you would have done well, there is no doubt about it. So what we have done here, we have written what is evolution in the introduction. Then we have explained what is microevolution and macroevolution. We have given examples and then we have concluded. If we want to add any scholars, you can use the ones who have given these genetic drift, migrations, this we have seen, Hardy, factors affecting Hardy-Weinberg law. Those scholars you can write here if you want to, and here you can write certain theories like Darwinism or Neo-Darwinism or something else like that. But even if you don't write, it hardly makes any difference because it is a pretty straightforward question. So the next question is Darwinism, salient features of Darwinism, and then criticism. So this is for a 15 marker. So here in introduction you can write that Charles Darwin gave this theory in 1859 in his book On the Origin of the Species by means of natural selection. Now, he was greatly influenced by Malthus theory, then he was also awestruck with the biodiversity of Galapagos Islands. Particularly finches, some birds which are known as finches. So huge biodiversity is there. They have modified their beak in such a way that they are adapted to different habitats. So these are different beaks that they have. These are the beaks of finches. So a different variety of beak enables them to adapt to different types of habitat. And another important event which led to this particular theory is discovery of Neanderthal fossil in Düsseldorf, Germany in 1857. So these led to this theory of natural selection, which he mentioned in his book On the Origin of Species by means of natural selection. So this you can write in introduction. Now the question asks about salient features. So salient features, you have to provide them in a logical way instead of writing them in a random format, because one leads to another and there is a logical correlation and coherence with this with each of these points. Say here you can present it in a chart form and then you can give a brief write-up. I will be presenting in a chart form. So the first point is overproduction. See, there is every living organism has this inherent potential and intrinsic passion for sex. They reproduce to produce more and more offspring. Some organisms reproduce at a slower rate and produce less number of offsprings, whereas some organisms reproduce at a faster rate and produce more number of offsprings. So there is a type of differential rate of reproduction among various organisms. Now, on the other hand, in the nature, resources are always limited. See, both these are actually facts, and these are the evidences also for Darwin's theory. So, in terms of food and breeding space, resources are always limited, and as a result of these two, say for example, this is point number 1 and this is point number 2. As a result of these two, it leads to struggle for existence. So because on one hand population is increasing, on other hand resources are less, they have to fight for food. Now this struggle for existence is of three types. One is intra-specific struggle. See, intra-specific struggle is competition within the same, it may lead to cannibalism. And the other one is interspecific, so it is a competition between two different species, maybe it leads to predation. And then environmental struggle, and no living organism is an exception to it. Every living organism has to face the wrath of the environment when environment forces them to accept. So overproduction and limited resources led to struggle for existence, and then because of this, or in this struggle for existence, there will be appearance of some variations. So they have to adapt to the situations and the circumstances which are changing. So there appear some variations among them. Now these variations are subjected to natural selection. These are subjected to natural selection. So nature selects the best or the fit and rejects the unfit or the variations which are not suitable to the environment. Herbert Spencer calls this as survival of fittest. So that means fit will survive, unfit will go extinct. Now after nature selected some variations which are useful, these variations are inherited. These variations are inherited to the next generation. So inheritance of useful variations. So if when these variations are inherited, to the next generation, for a period of time, it leads to formation of new species. Technically it is known as speciation. So you have to write these points in the same order, then only it will be logical. You can't change this order. So overproduction, limited resources, struggle for existence, three types: intraspecific, interspecific and environmental. Appearance of variations, natural selection or survival of fittest, and then inheritance of useful variations resulting in the formation of a new species, speciation. So these are the salient features. You can draw chart like this, and then you can give a brief write-up after following this particular chart or diagram. Then criticism. You see, there is an inherent weakness of Darwinism. That it is unable to explain the basis of variations and mode of transmission of these variations, because 1859 the concept of gene did not come into existence, because in 1865 Mendel proposed his laws of genetics. So maybe this is one of the reasons why this knowledge was not there, and this becomes the inherent weakness of the particular theory. Now, this theory also fails to explain appearance of small variations, like small wings of a bee, bird, or an insect. See, this particular theory also cannot explain the over specialization of certain structures, like the tusks of elephant or the antlers of deer. So cannot explain. So these cannot explain. I think I'll better mark these things. Cannot explain appearance of small variations, cannot explain over specialization of some structures, also cannot explain degeneration of some organs or some structures. It also could not explain the presence of vestigial organs. Obviously, it also could not explain the discrete and discontinuous variations. So these are the drawbacks of or criticism of Darwin's theory. But Darwin has number of proofs. This is a fact, this is a fact, this is a fact. Number of variations are there, this is a fact. And even natural selection, just like natural selection, we can prove it in artificial conditions. That is selection done by human beings, which is artificial selection, which is what say mimics natural selection. So there are a number of evidences which are in favor of Darwin, and that is why the norms of Darwinism are generally seen as the norms of evolution, because evolution is slow and gradual, and it takes place over a period of time, and the variations are also slow and gradual. Discrete and discontinuous variations are related to mutations. So these are the points of criticism. Then you can conclude by saying that it plays an important role in evolutionary biology, and this has revolutionized the human thought process or human beings thought process. And in this particular period, in 1859, all the divergent views on human evolution converged at one place. Scientific view of explanation of human evolution superseded the supernatural theories. You get my point? So this is how you can conclude this particular one. So these are the questions and the explanation. As I said again, I will remind you one more time, make sure you write regularly and complete the program, complete the 60 days program. So it shows that whoever completed this test is properly, inevitably scored good marks. Next one, make sure that you practice this test in a time bound manner for example, today's questions, if you see, so you have two 10 markers. So you two 10 markers, so that means 2 into 7 minutes, which is 14 minutes, 1 into 10.5 minutes for 15 marker, that means 10.5 minutes. So approximately some 24 to 25 minutes you have to complete these questions, and if you are taking more, it is of no point, because in exam you will not be given surplus time, and it is very important that you practice in a time bound manner. So these two things is something which I am suggesting you, and I urge you to follow these two religiously. So complete the program, make sure you do it on regular basis, and take the tests in a time bound manner. That means adhere to the time limit. Do not exceed. Do not exceed. So that's all about today's 3 questions discussion. I'll see you in the next class. Thank you very much. If you have any questions, you may definitely reach out to me through the phone, or you can come and meet me in person from 11 to 12, and then evening 5 to 7. So that's all for today. Thank you very much.